It's so easy to make that.
Yeah.
What's in
I
that?
always see that every day.
Nice. You ever seen
Junior,
really play it?
junior skip that. I guess none of the juniors are starting up to school. And seniors? Sophomore.
Oh, they go there. Grades and
No, oh, I was in ninth grade.
I think it was ninth grade.
Something you beat it.
So, Tuesday is grade 11 and 12, sixth grade. Wednesday is grade 9. Thursday is grade.
Sophomore skip day.
I'm not going to do it. No. Thursday.
I ain't going to sixth grade.
Good morning, Glenrock Middle School. Today is June 8th, National Breast Cancer Day. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
Was the person who owns a 44 black with a license plate R70-NCD, please remove your car immediately.
All right. We'll get started after our Pledge of Allegiance, unless your window will be. But
Here, there's never 40 dozen. Nothing's already said. Oh, she's invisible. Layers. She's invisible.
Good morning, Glenrock High School. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
all right. All right. So yesterday you didn't have any homework for me. Okay. So, but after today, because we're gonna have probably possibly 2-day break from math. During those 2 days, I want to make sure that you guys are getting the homework that you need. So take out your notebook and start working on this problem for me while I take the attendance. I know it says exit ticket at the top, but it's very similar to what we did yesterday. You start an account with $500. Remember, if you require the formulas once again, you should have this in your notes, but this was from yesterday, right? A times 1 plus the rate to raise to the power of X. So 1 plus the rate will be the growth, and 1 minus R will be the decay. So keep that in mind, and then get started working on this for me. Yeah, sure. Yeah. Oh, actually, I'll just write it for you here. Okay. So the growth will be A times 1 plus the rate raised to the power of time. Decay is the same thing pretty much, but it's 1 minus R, like this. Yes. Interest rate means it's going up. Yes. Yes. Does anyone need a calculator here by any chance? Yeah. Okay. All right. So okay, we are going to get started with going over this one particular problem. We really haven't talked about the growth or decay factor, but that essentially is a fancy word for saying what are you multiplying each time. So first, I think I told everyone in this classroom, and for those of you who heard me, sorry, it's going to be an exponential growth function because when we talk about interest rate, usually what we're talking about is the money is getting like, compounded more and more and more on top of whatever that you have originally. Identify the initial amount, the exponential function, and then actually solve for it. Connor, can you walk us through what you did?
I'm not exactly sure if I got it right.
Yep.
Do you want just the whole expression?
What will be the initial amount for this though? $500. And then can you actually tell me what the expression, the full expression would be?
500 times 1 plus 0.0.
Perfect. And then raise to the power of 3, right? So here, this is going to be the exponential function to model the situation. And then all you got to do when we say we do the problem, that's just a fancy word for saying also like actually type it into the calculator. 500, 1 plus 0.06 raised to the power of 3, 595.50 cents. If you put 8 at the end, not really realistic, or maybe 51 cents. 51, that's good. So we want to say, because we're talking about money, it really doesn't go below a penny, right? So there we go. We get total amount of 595 and 50 cents, 51 cents. The growth and decay factor, this is where this inside the parentheses is coming from, but I'm not really going to ask you a question in part C. So if I were to ask you what the growth/decay factors were, you would say that you're multiplying by 1.06 each time, okay? Very simple stuff. So all I'm asking you to do from yesterday was applying the rules and figuring out how to do this how to do these types of problems. Today, I think it's gonna be a really good introduction to logarithms, and I'm gonna show you guys how to use logarithms to solve basic questions like these. So I'm gonna show you right now. That's right. Yeah, I think it's this one. Okay. So we had this question yesterday, and I wanted to just kind of build upon from that idea, and I'm going to erase this, it's getting in the way. So here's the proposition. You buy a new computer for 2,100 bucks. Okay, the computer decreases by 50% annually, and I told you guys yesterday that that's not really realistic. But we're gonna go with that context. When will the computer have a value of $600? It says. Okay, so it says when will the computer have a value of $600? First of all, can you guys all just take a look at this for me, and then just write down the exponential modeling equation based on this. So we're talking about decreases 50% annually. X for the time. Sure. Does anyone have a guess how to write this? Yep. This is
600 equals 2,100.
Yep.
Which is 1 minus 0.5,
To the x power. Great. So hopefully you guys have something similar. I'm gonna just write this a little bit bold for you. So 600, 2,100, 1 minus 0.5 raised to the power of x. Like if you were to do that, like on the right hand side, I want that thing equal to 600. Okay. So right away, I can probably just do this portion, like 1 minus 0.5. Well, that's easy. That is 0.5 right there. Okay. And at this state, we get stuck because what will be our next step be here? Like if I were to solve for x algebraically, anyone coming up with a multiply by?
multiply half by 100.
Oh, so you're multiplying these two together, right? Okay. The only problem with that though, good try. It's you ever PEMDAS?
Yeah.
So like exponents must come first. So what that means is I actually have to take care of this thing first. Square root, that's only when this thing is 2, right? So the first thing we always must do is because we got to do this first and this second in the opposite direction, we want to get rid of this to the other side. So how do we get rid of this 2,100 times whatever this says? Think of like 2,100x, if you will, divided by, right? We just kind of like get rid of it by just dividing it away. And I'm just going to do 600 divided by 2,100 on the side here, and I get 0.285714 is equal to 0.5 raised to the power of x. Now, I know it gets really complicated here. So now that I'm asked to solve for something like this, where x is in the exponent, okay? Or how in the world am I supposed to solve for this type of stuff, okay? This question, okay, the purpose of logarithms in which I'm going to ask you guys to apply to is it's really useful to find out this time. How, like you can predict how long is it going to be. Let's say this could be really applied to anything. 2,100 computer becoming 600 after about these many years or these many months. $2,100 sneaker. Let's say it's decreased by its value and only get up to 600 after how much time? When can you expect the value to decrease by that much? This is where the logarithm is going to come into play. And I'm going to show you on your calculator, if you guys could just pull that out for me. Okay, so we're trying to solve for something like this. And I really need you guys to have, well, I think on the iPhone calculator, this works too, but it's really much more applicable if you have one of these things. Okay, so Texas Instrument calculators here. Okay, this button right here, log, this takes care of pretty much everything. Okay, so what log allows it to do is it allows us to bring this exponent. The whole problem with this is that it has the exponent up here, and it really doesn't have anything to do with the coefficient. So what we're gonna do is we're gonna call this like taking log on both sides of this equation. I think I am kind of going back on track. Actually, I'm gonna just save this up for later. Actually, solving logarithms like doing algebra portion. But I am going to first go over the basics with you by talking to you guys about this. So unfortunately, we're gonna have to put a little pause button on the previous problem. And let's just go over the basics of how to do certain questions like this, okay? And I want you guys to focus on maybe just 3, 5, and 7. What you will notice is that x for all of these questions are in the exponent zone. They're not in the, like, it's not 3x. It's like 4 to the power of 5x is equal to 4 to the power of 10. Some of you guys could probably already figure out 3 right away, right? What is the value of x going to be here, Connor? It's going to be 2. And Jason, can you take the next one? What do you think the next one? Well, what would I do to solve 5 here? Okay, so you know that this was 2 though, right? Okay, how did you know that this was a 2? So then this thing and that thing had to turn out to be the same thing. Here's the same situation. I have 9x and 7x plus 8. Those 2 are the exponents, right? What do I got to do with those 2 things? I have to make them equal to each other. That's it. So here I'm going to say 9x is equal to 7x plus 8. And then let's say I do the algebra portion. This is like pre-algebra, right? So let's say I move the 7x here. What would I get? I have to subtract it, right? So what would I get? 2x is equal to 8. Therefore, x is equal to a 4. Okay? This is how you would solve it. The whole reason why you guys can all do this is because they all have what we call the same base. Okay, as long as I have the same base, it works out perfectly fine. Like the 4 to the power of this is equal to 4 to the power of that. Okay, so that means this and that has to be the same thing. 3 and 3, they're the same base, so this and that also has to turn out to be the same thing. Okay? Now suppose I'm going to skip all these questions and go straight to here. Like, let's say I ask you for something like that. Okay? So 3 to the power of b is equal to 17. I really can't figure this out where what the b value is, because we only know from the integer perspective, like, you know, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. Like those values are pretty easy, but none of these numbers will give me 17 here, right? Max, what's 3 to the first power? No, that's 3 to 0 power is 1. 3. And what about 3 to the second power? 3 to the third power? 27. So what that means is this 17 is somewhere between like 9 and 27, which means the b has to be somewhere between 2 or 3, give or take, right? So how do we figure this out? Can you guys all write this down for me on your notes? This is the logarithm slide. This one. Okay. So let's say that I give you, this is a lot of arrows here, but all this means is if I have something base raised to the y power, like for example, in the previous problem, we had 3 to the power of b is equal to 17. If I ever have an exponential equation like that is equal to x, what I can do is I can relate that to a logarithmic expression that allows us to calculate what the y value is going to be for us, okay? Log base b, we call this log base b of x is equal to y, if and only if base b to the y power is equal to x. And here's an example. So we start off with this. 3 to the y power equals 27. If I were to write that using logarithms, that's what it's going to come out to be. And don't worry, I'm going to give you plenty of practice with the logarithms and going over the basics with these. But first of all, I need you guys to have one of these handy. Like, does everyone have this one? Max, you need one, right? Okay. That one works too. What's up, right? That one works, yes. This is the last one. So would you be able to pull it up from the laptop? Yep. Adriana, I don't know if this will work, but can you go to math and then on your calculator, the math button, and then keep on scrolling up? Do you see this log base? That's what I was afraid of. Can you actually pull out your laptop instead? Yeah, because the TI-84 color edition, they always have these things functions, but the 83s they won't. So if you have the 83, those of you on Zoom, just try to have the laptop out, the NJSLA practice test, and go to the calculator here. Okay. So here's the thing I want you to type along with me. We want to type log base 3 of 27. A lot of you guys a lot of the students that I experienced, they got confused because there's a log button right here on the calculator. It's one of those like it's left of 7. But if you do that, like it just straight up says log. It doesn't give you that little space after log to put input a 3. When they just tell you straight up log and there's like no number at the bottom, that just means that the number is 10, and we do not want that one. So here's what I want you to type in. Could you guys all please go to math right here? Press math, and then you're gonna keep on scrolling up. Do you need help with you got it? Perfect. You gotta keep on scrolling up, go to log base, which is alpha A. Well, the letter A. And if you click enter or press enter, there we go. That's the thing we want. So we want to type in exactly what this thing says right here. Log base 3 of 27. Can we all please type in 3? Scroll right one and type in 27, please. And then press enter. And then look at that. Okay. Log base 3 of 27. Now I'm sure that you guys have not raised any if you have seen this before. Logarithms, never, right? So logarithms is really unique to algebra 2. I'm like exposing you to something that's beyond like just doing x's and y's. Okay. All right, so, and you guys have to understand what this means. This means that if I were to take 3 raised to the power of 3, because we just solved for y right here, it gives you 27. Is that true? 3 raised to the power of the answer that we just found out. I did answer that we're doing second negative sign. If we do that, it gives you the answers. And if I press enter, there we go. I get 27. So I go back to the exponential equation. So I can swap back and forth. Does anyone have any questions about this? You guys all okay? Guys, you guys have to follow along with me here. It's really important that you know this. Now then, if I give you guys if I go back to this question, okay? Let's use logarithms to solve this, okay? I want to find out the exact value of b, where if I were to take the 3 raised to that power, I get 17, or maybe being close to 17. Using your notes, can you guys write down for me what the equivalent logarithmic expression would be? Okay, so it's base b raised to the power of y is equal to x. I think that was the notes. So this is 3 to the power of equals 17. Use your logarithmic expression. Okay. Tell me what the logarithmic expression would be here. Do you guys need to see the notes again? Yeah, okay. Guys, please write this down, the logarithmic notes, which is here. Okay. If I give you if I give you this, 3 to the y equals 27, then whatever this number is, whatever is being raised to the power by, that belongs right here in the subscript. Then the number on the outside, 27, goes after that. Whatever the exponent was, it becomes like equal to the other side. Okay? The example might be more applicable than this because there's just too many letters to deal with here. Let's just really focus on this right here, okay? 3 to the y power equals 27. That means log base 3 of 27 is equal to y. Okay, so now let's go back here. Try to memorize it the best way you can. And let's try to write down the logarithmic expression of this. Anyone have a clue? Braden? Yep. Yes. Yeah, so log base, so we want to say log base 3 of 17 is equal to b. The output would always be your exponent, whatever number is being raised to power by, that is a subscript, okay? So we call this log base 3 of 17. So can we all type that into our calculator now? Math, scroll a couple of up here, scroll up a couple times, log base 3 of 17. Then once you're ready, please press enter.
Wait, what? So you got exponent be y? Or not the variable be y?
No, but it's for this one, the variable says b.
Oh,
So
Log, like,
it just gives you, it doesn't give you this, right? Okay, because you're just pressing this button right here. Go to math button, press math, scroll up a couple times. There should be something called log base.
oh, log.
That's what you want to use. Okay, guys, press enter here and look at that. We get 2.57890193. There is no way for us to calculate them. Besides, remember the time when I said, oh, I know the answer is somewhere between 2 and 3 because the answer to 17 is somewhere between 9 and 27. Okay, so let's check to see if this really is the correct answer. If that was equal to b, then what I can do is I can do 3 to the power of 2.57890193, and I should expect to be 17, right? Okay, so let's try it. 3 raised to the power of 2.57890193. Look at that. Okay, so this, I cannot solve this by hand. Like, there's no way for us to do that. This, you have to heavily rely on your calculator, and you need to have your TI-84 with you. I have extra spare 3 of them that I can lend out to you. But you need to learn how to do this. It allows us to calculate the exponent in the equation. All right, so I'm gonna give you guys this rest of these 3 problems to do. So 16 v is equal to 67. Please try that one. 9 to the power of n equals 49. 12 to the power of r equals 13. Please write down the equivalent logarithmic expression for each and every single one of them and use your calculator to solve it afterwards. Okay. Use this as an example. Tell me what the logarithmic expression would be. Yep. Even though it has these little decimal points, yeah, that's because that's because there should be more decimal points afterwards.
So all you usually have to do is plug it in that. Is there any, never have to plug it in differently? The guys put 16 in
The base,
and then 7 into
the parentheses. Yeah, for now, yes, absolutely. Yep. Because I want you guys just to get the hang of how to, whenever you guys see this, logarithmic form right away. I need you to solve for v. I need you to solve for n and r and such. Yeah, and if it's one of those things that's new that you guys are going to be exposed to in Algebra 2 is this, logarithms. I'm really glad that we really hit that milestone. And I know that this week is going to be hectic. Tomorrow we drop, Thursday, some of you guys are not going to be here. So I really get to teach you guys something extra on Friday. And next week is like the last full week of, I think, school.
something you're Ron complaining about these.
Ron it? Why? What did he say?
He complaining about logarithms.
Did he really?
Yeah.
What did he? Do you remember specifically what he complained about?
He like tried to showing me like I don't know. I think it was not this.
Oh, was it something else then? But it was logarithms?
It was logarithms, but it didn't look like this. Like,
Oh.
I don't know.
Okay. 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 It looks much more complicated though, right?
Yes.
Okay.
It's not similar to that. Yes.
Are you guys all okay with this stuff? You guys got it? All right. So I'm gonna ask for everyone to volunteer here. So Adriana for the 16b equals 67. What'd you get? 67? Okay, so 1.51652222. First of all, tell me the equivalent logarithmic expression for this thing. 16 of 67. 16, right? And then that's equal to v. So we want to say log base 16 of 67. And then when you type that into the calculator, go to math, scroll up 3 times. This is 16 and 67. And then boom, just write that down as your final answer, and that's it. 12 to the power of r equals 13. Oh, always, I need you to tell me the equivalent logarithmic expression. Dan? For this one, 12r equals 13?
Log 12 and 13.
Of 13 is equal to r, right? So I'm going to do that. And what do you get for your final answer here?
1.03221155.
There you go. So 2211, 555. So if I were to take 12 raised to that power, if I do second negative sign, that gives you the answer. I don't feel like typing all that in, and it gives me 13 right away. Okay. All right. So then that last one here. Jacob, do you have this one?
Yeah, I got 9 to the power of
1.77124. Okay, 24. All right, and can you tell me the equivalent logarithmic expression for this?
log 9 times.
Of. We don't want to say times. This is log, like log of 49. Log base 9 of 49. That equals n. So math, again, I'm going to show you this many times here. Not 9, 49, and then there we go. 1.771124. Okay, so I'm hoping that you guys all get this stuff, and I'm gonna go back to that little word problems that we did right here. Okay, do you guys remember at the very beginning we started off with you buy a new computer and the computer decreases 50% annually, and we got really stuck here. Okay, this is where we left off at, and now I'm gonna play the play button one more time. Can you guys all now use your knowledge of how to, just because it's decimals doesn't mean it changes anything. Use your logarithmic expression, equivalent logarithmic expression to solve for x for me. It's very similar to the one we just did before. Only the fact is now it's decimals now. And then after you solve for x, please check your answer by plugging that in way up here, trying to see if that after that many time, do you really get $600 afterwards? Yes, Jason?
Is that 6 or a 5?
You mean this one?
Yeah.
That's a 5.
Wait, which one is your base?
The base is, remember, the base is always this number because it's the number that's being raised to the power by.
Okay.
Yep. Jay, you don't have a calculator, right? Yeah.
No,
I was gonna ask you if you could tell me the answer with this
I
one.
could do it.
Sure. Yes. Take your time. And then let me know when you have the logarithmic expression.
Alright, I got it.
Okay. Yes. What is it?
1.807356365.
That is equal to x. Can you tell me your logarithmic expression that you use to solve for that?
I'm gonna log 0.5
Uh-huh.
of 0.285714.
That is perfect right here. So when we do log base 0.5 of 0.285714, that is the equivalent logarithmic expression of what we see right here. Why is it so delayed? Okay, there we go. So now I'm going to also try myself and then make sure that, this answer is correct. So log base, and then we're going to do 0.5, 0.285714. 1.807, but what we want to do is we want to use that and check to see if that answer really works up here or here. So if I do 2100 times 0.5 raised to the power of the answer, okay, second negative sign, because I don't feel like typing all that in. Let's see what happens. 600. I know it says 599.9, but that's very close to being 600, right? Why is there a small discrepancy there? Well, that's because I rounded up this number. Supposed to be like 0.285714, like 222, like something. There's a lot more decimal points afterwards here, but I just kind of cut there. That's why I'm not getting the exact 600. But it works. So this is how I can predict how long is it going to take for certain values to decrease like this. Do we all follow? Okay. All right. So we're, believe it or not, we're actually nearing towards the end. And I know that I'm going to give you like maybe about 10, 15 minutes towards the end of the class to, for you guys to take a break, or if you guys would like to work on something else, then I'm going to give you that. Okay. All right. So let me give you one more word problem. And this one, I'm going to ask you to do it by yourself. Before that, do we have any questions? Are we all okay? Okay. Could you guys take a look at this problem for me and then find a value? Let's say like you are the person who's in charge of the finances, and I ask you, okay, tell me how much it's going to be after 4 years and predict when it's going to be equal to 500. Like I'm the president of the company and I want to know these two facts about this particular slow motion I'm about to sell. All right. So using logarithms, using exponential functions, please try this with number 1 and 2.
Mr. Kim, do we have to use the logarithm for the first one?
You have to use logarithms for the second one. Because whenever they say when, like when will something be, that's like, oh, that's your cue for I gotta use logarithms.
Okay.
Yeah. Do you have the log base on that calculator? Can you, because it only has logs though, right?
Yeah.
Okay. Jay, when you're using that calculator for logs, I can show you how to use it. Let's say that you're trying to do log base, I don't know, like 2 of 20. You can just type in regular log of 20 over regular log of 2. It will give you the same answer.
Oh, minus.
Yes, it depreciates.
I went too far.
Oh. Yeah, because usually when we're buying like machines or technical products, they don't appreciate in value. They usually depreciate.
Wait, in order to check it and plug it back into the equation used for the first part?
No, you plug into the equation that you made for without the 4 years plugged in. This one, so you are making the equation, right?
Yeah, no, but you're not plugging in the 4.
You're plugging whatever you got here. Yes, absolutely. Thanks for checking. Perfect. This is actually this second answer. This is perfect.
Actually,
Yeah.
I did.
I think you did something. So you see, I see you opened this part.
Oh yeah, I did.
Yeah.
Wait, what part? Yeah.
This is part of this story, but down in front of us. That's the answer. Yeah.
So I just do the, so I divide it by the base one.
Yes, you divide it by the log of this one.
Okay.
Yeah, and the log of this over one.
Oh, wait, is this?
That is the answer to that. Oh, you know what? Because you do 1 minus and not 2.
Should I write the whole answer?
Look, this 0. This is this is perfect. Perfect, great. Well done. Perfect. The first answer is this one, is 100. And then, oh, you're working with the second one. Here's the number 2 question.
I put it into like the, log formula.
Yep.
Do I have to do anything after?
Because if you're telling me that's your final answer, that is actually not correct. So log base, huh?
I put in,
No. Because remember how we have the 3,500 is like the original amount. You want to divide that away. So you mind if I borrow your computer? So we have to set up an equation that says 600. I'm sorry, 500. Okay, that is equal to 3,500, right? Times 1 minus 0.25 raised to the power. And you gotta first write that down. Then we do divide both sides by 3,500, like we did before. Cancel this out. We have this thing left over. Right? Can you cut the new calculator? No. 500 over 3,500. You gotta do just a little bit more stuff. There you go. So you do see this, right? 0.1428. So can you just write that down for me right there? Yep. And then it's equal to what's 1 minus 0.25? Okay, so write it down is equal to 0.75 raised to the power of 2. Now can you use that to write the logarithm expression? So what belongs in that? There you go. Yep. Have you actually had all of these before?
No.
Okay. Because I really want to try the SpongeBob one, but
Sounds like the ice cream.
yeah.
The ice cream thing.
Yeah.
I think the chip weights was just like secure.
Yeah, that's what I said.
You said chip weight?
Should put your items down.
Yes.
This is hard. I got to choose one.
I did.
This is tough.
I'm actually with Dan completely. Chip weights.
Chip weights is like.
Creamsicle is really good,
Guy?
but the only knock on creamsicle is everyone just wants that cream. Like the orange is too
I always
low.
wanted to try the strawberry shortcake.
That's good. Oh, it's good. It's good.
Really? I have to go with either.
Sipping likes the SpongeBob.
Horse.
This is tough.
He likes
know,
the SpongeBob.
it's
He likes the
tough.
SpongeBob bar.
You make this one wrong choice and you just wasted.
Your whole life.
That I can show you know.
Your whole life. Let's think about your whole life.
Isn't that one of the most horrible feelings when they say they don't have it anymore?
Yeah.
This is loser there. I gotta go with either like King Kong.
You're going wild.
King Kong? Yes. King Kong or I was debating between King Kong and when I was in middle school, you know the chocolate chip ice cream like sandwich.
Yeah.
I really used to love those.
The chips out.
Usually chocolate ones that I like.
I'm allergic to nuts, so like,
Oh,
Yeah.
I had a taco one time and it
Taco,
almost killed me.
taco. That's actually good.
Yeah, the
Have you
gunner
ever
one
got the lemon chill? It's like a little.
I've never
No,
heard of
no,
it.
it's always a
No, I really had like.
Please write down.
I like
blue
the
raspberry.
first
I'm
one.
a blue raspberry.
It's 25%.
Can we get the SpongeBob bar?
Why did I put SpongeBob bar?
I mean, it's close, but you know, it's kind of giant.
Oh, really?
What?
Big cells.
I know, yeah.
Big cells?
How you doing? Sure. Let me help you with this. All right, so we're gonna end with this slide. Please write down along with me. Find the value of the snow machine after 4 years. You guys were all perfect with that. 3,500 times 1 minus 0.25 raised to the power 4. I believe it was like 1,100 something. Can someone help me out with this one? Dan? $1,107. 0.42 cents. There we go. So I know that it was like 1,100 something, and I'm sure that's what you have, right? Okay. The next question is the stuff that we learned today. When will the snow machine be 500? So we say 500 is equal to 3,500, 1 minus 0.25 raised to the power of t. Like we still want to write that expression out. Okay. The only thing that's missing here is the value of t. Okay. And then this one requires you to do some sort of a pre-algebra section before you jump into the logarithms here. 3,500 divided on both sides of the equation like we did before. 0.1428. Is that right, by the way? 571429, right? Okay, that right here is equal to 1 minus 0.25 raised to the power of t, or better yet, why don't I just rewrite this as 0.75? Okay. So with this, we want to write down logarithmic expression here, okay? Connor, can you tell me what the logarithmic expression would be for this one? What goes down here? There you go, of the big decimal point. So I'm going to just copy and paste this right into here, okay? And that is going to equal whatever the answer that I'm going to get. So log base of 0.75 of 0.1428571429. That becomes, I believe, 6.76 years, right? And then let's say I want to verify my answer by plugging it back here. I'm going to use my calculator to do that. Oh, thank you. All right, so if I go back here, this logarithms, and then we're going to go base of 0.75 of 0.14285149. I'm sorry, what am I doing? So we already did that. And then we're going to do 3,500 0.75 raised to the power of 6.76 years. All right, about 500 and extra 59 unwanted cents, but we're right on the ballpark here. Okay, so this is how we do these types of problems. All right, that's it. All I have for you guys today. I'm gonna give you guys the assignments on not just these types of questions where after a couple times, you know, how much money is it gonna be afterwards, but also when will the value be this matching up to, like, let's say for example 500 by using logarithms. Okay. All right. Emma, I'm gonna post a video. Like, there's a recording of this, so YouTube video, and you can watch that from there. Okay. Perfect. Those of you on Zoom, if you guys would like to log out, you guys can, and have a great day. And for those of you here, we still have about like 6 minutes, 7 minutes left. And then I'll dismiss you afterwards.
They don't have to do the chip whip, we'll get the ice cream sandwich. We don't have either, and we'll get the ice cream
That's the most important, is like your third option.
Then I'm getting the crepes as well.
Oh, thank you.
And sweet orange.
One time I was at the boardwalk,
And they were like handing those out for free for some reason.
No.
The one kid got one.
It's the real
And
bird.
he like took one lick and it stuck to his tongue, and he couldn't get it off, so they had to call the ambulance because it was like completely stuck to his tongue.
Ambulance.
Yeah, what do you call it?
Ambulance. The ambulance?
What do you call it?
Ambulance. You said ambulance.
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 Whatever. Well, you know what it is. They had to
No,
call
I
the-
don't.
They had to call the hospital, and then the kid came. They had to come rip it off his tongue. It was like,
Rip it off his tongue like.
They don't like rip it off his tongue, dude, because they had to like put like stuff on his tongue. Yeah, they just, I don't know. They like put something on his tongue to like get it off. Because like it was stuck. And, like,
That's kind of sketchy. People just hold the wire on your ice pick for
yeah. Well, I think it was like a fun. There was like a fundraiser or something.
Our department called New Logan Falls.
We don't know what's important thing about it. Definitely intended to do that.
All right, so the time is 8:48. I think that's time. So have a great day, everybody. And I'll see you guys. I'm not sure when I'll see you guys, but I'll see you guys next time.
Eventually. Thank you.
Thank you. Take care.
Thank you.
Thank you.